We've seen that functional dependencies can be useful weapons in the fight against the evils of redundancy. And so given that we have some functional dependencies, it would be nice if we could turn them into even more functional dependencies. And it seems like that should be possible. So let's look at some examples. If we know that book ID determines the pair publisher and author, then we know for sure that book ID determines them individually. It determines publisher and it determines author. So those are extra functional dependencies we can write down. Similarly, if we know that book ID determines publisher and book ID determines author, then book ID determines the pair, publisher-author. And so that seems to go both ways. Also, if book ID determines author and author determines publisher, then by transitivity we'd think that book ID determines publisher. So those all make intuitive sense. Let's look, however, at a counterexample. If we have a pair title, author determines publisher, that does not necessarily imply that title determines publisher, nor that author determines publisher. Let's think about that. There may be many books with the same title that have different publishers, so that makes sense that that doesn't work. And an author may write many books and change publishers over time, so author may not determine publisher either. And so somehow we can't take apart the left-hand side of one of these functional dependencies and apply its pieces to the right-hand side. So we're going to need some rules for how to reason about these things. Most generally, what we want to say is that some functional dependency G is implied by a set of functional dependencies, capital F, if G holds whenever all the FDs in F hold. Okay, and more generally, we can write down F plus, which is the closure of F. It's the set of all the FDs G that are implied by F. This includes the contents of F, of course, and it includes trivial dependencies like A determines A, B determines B, but it may include other things as well. So how do we get the closure of F? Well, we're going to have some rules of inference. They're called Armstrong's axioms. They're not actually named after Louis Armstrong, the pioneering jazz trumpet player. They're named after William Ward Armstrong, a computer scientist. And there's only 3 of them, so they're easy to remember. If we're given 3 sets of attributes, x, y, and z, the first of Armstrong's axiom is reflexivity. If x is a superset of y, then x determines y. And that seems fairly straightforward. We've seen examples of that in our previous slides. Augmentation is the second rule. If x determines y, then xz determines yz for any z. And then finally, transitivity. If x determines y and y determines z, then x determines z. So it can be shown that these are correct. These are sound rules. It can also be shown that they're complete, that all of the functional dependencies that can be derived from F can be derived through application of Armstrong's axioms. So this is a sound and complete set of inference rules for functional dependencies, which is a really nice, simple basis for reasoning about these things. There are some additional rules that are really just macros of Armstrong's axioms, but they're nice to remember because they're handy in proofs. The union rule says if x determines y and x determines z, then x determines yz. We saw this in the previous slides as well. And the decomposition rule, if x determines yz, then x determines y, and x determines z. All right, and it's useful to try to prove these using Armstrong's axioms directly, because as I said, they're sort of macros of those axioms. So see if you can prove them. Let's look at an example. We're given a schema contracts. It has a CID, contract ID. It has an SID for the supplier. It has a JID for the job. It has a DID for a department. It has a PID for a part, and it has a quantity and a value. C is the key. So the CID is the key. C determines the entire contracts table. Project J purchases each part P using a single contract. So JP determines C. And then each department purchases at most one part from a supplier S. So SD determines P. All right, so that's our given set of functional dependencies F, are those 3. Now we'd like to prove that SDJ is also a candidate key for contracts. Well, we know that JP determines C, and C determines everything. So by transitivity, JP determines everything. So JP is a key, which is not what we wanted, but it's interesting. We also know that SD determines P, which implies by augmentation that SDJ determines JP. And you can see where this goes. Now, by transitivity, SDJ determines JP, and JP determines everything, so SDJ determines everything. And by transitivity, then, SDJ is a candidate key of contracts. Now, can we therefore infer that SD determines everything in contracts except for J? And the answer to that is no. just the same way as it was with our books and our titles. You can't just drop things from the left-hand side and say anything about the right-hand side in particular.